There are four fundamental forces that govern how the universe works. These are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The first force, gravity, is something we have all heard about. It describes how massive objects attract more mass towards themselves. This is how the moon stays in place around the Earth, or how the planets orbit the sun. However, smaller particles, due to their mass, are unaffected by gravity. The next force, electromagnetism, describes the behavior of charged particles as well as magnets. When two magnets are placed with the poles facing each other, the magnets will repel each other, but if you place opposite poles facing each other, they will attract and join together. This is similar to how charged particles work. Protons near each other will repel away from each other because they both have a positive charge. Meanwhile, a proton and electron will move towards each other because of their opposing charges. There is a close relationship between electricity and magnetism, which is why electromagnetism is considered a single force. An example of this is how a coiled wire with flowing electricity generates a magnetic field, which allows for a magnet that can be toggled. This works the other way around. Rotating a coil around a bar magnet will cause electrons to flow through the wire. The remaining two forces operate on subatomic and quantum levels. This will become clearer after I explain them. The strong nuclear force describes how particles stick together, such as the quarks in a hadron or the nucleons in the nucleus of an atom. This force also helps us explain how protons remain stable in a nucleus without repelling each other. The strong nuclear force is powerful enough to overcome the electromagnetic force because neutrons act as a cushion between the protons. The weak nuclear force, hence its name, is basically the opposite of the strong nuclear force. It helps to describe how heavy quarks decay into their lighter cousins, or how beta decay works. You may be asking how all of this fits into the picture of fundamental particles. If you remember, we looked at two categories of fundamental particles previously. The third category is linked closely to the fundamental forces of the universe. These particles are called bosons, also known as force carriers, and as their name suggests, they intermediate these forces. Gravity does not apply to these particles, but that is not important for the time being. Right now, I will introduce you to all the particles, while I discuss each force and its bosons in detail in their own short series. There are seven bosons discovered so far. The photon is associated with electromagnetism, while the gluon is related to the strong nuclear force. However, unlike these forces, the weak nuclear force has three bosons dedicated to itself: the Z boson, positive W boson, and negative W boson. The seventh boson is called the Higgs boson, and this is the most interesting of them all. Keep an eye out for the short series I'll be uploading over the coming weeks.